In this video, we're going to be looking at how to find the series for a geometric sequence. And if you don't remember, a geometric sequence is pretty much a sequence for which the previous terms from the next have a common ratio. So in this case, you're timesing by 2 to go from 5 to 10, and then from 10 to 20. So this is a geometric series. If we want to find the sum of the first n terms of this series, we can use the following formula. We can use the formula a times 1 minus r to the power of n all over 1 minus r. And in this case, r cannot equal to 1. And the only reason r cannot equal to 1 is because we will have a situation where we're doing 1 minus 1, which is dividing by 0. And that's just not allowed. So this is what the formula for a geometric series is, and it's pretty much summing up all the terms in a geometric sequence. So let's have a look at a few problems. Okay, here is question number 1. We're given that a sequence follows this pattern here, goes 5, then 10, then 20, and we can recognize that each term in this sequence, if we compare the next term from the previous, we have to multiply by 2. Okay, so this makes it a geometric sequence with a common ratio of 2. So we need to find what S10 is. We need to find the summation of the first 10 terms. So the series equation equals to A, which is the first term in the sequence, times 1 minus r, the ratio, the common ratio to the power of n, divide 1, take r. And again, r cannot equal to 1. And in this case, we can clearly see that r is 2. Our ratio is 2 here. So what we can say is this is going to be the same as the first term, which is 5, times by 1 minus 2 to the power of, in this case, 10, because we're trying to work out S10. And we can do all of this divided by 1 minus 2. And if we put this into our calculator, we get 5,115. So this is the summation of the first 10 terms in this sequence. This is our next question. We have another sequence and we're required to work out the series for the first 6 terms. So let us first work out whether this is an arithmetic or a geometric sequence. So comparing each number from the previous, okay, if we have a look at it, to go from 1 to negative 3, we have to multiply by negative 3. To go from negative 3 to 9, we can multiply by negative 3 again. So we can recognize we have a common ratio, so that makes this sequence a geometric one, where we're multiplying each term by negative 3. So now if we want to work out the summation of S6, S6 is going to be equal to, in this case, the first term, which is 1, times by 1 minus the common ratio, so minus 3, to the power of n, which in this case is 6, because we're trying to work out the sum of the first 6 terms, all over 1 minus 6. And in this case, I made a little mistake. It should be over minus 3. And this would simply be equal to minus 182. Okay, this is our next question. How many terms would it take to get to a sum of 3096? So first thing we can recognize is this actually a geometric sequence? And in this case, to go from the previous term to the next, we have to times by 2. So that means r is simply equal to 2. So now what we can do is we can simply use our summation formula. So the series formula is Sn equals a 1 take r to the power of n all over 1 take r. You already know this. And the first term here is 3 times by 1 take the common ratio 2 to the power of n. And n is what we're trying to work out, so I'm just going to leave it as n. All over 1 minus 2. And we know that the series must equal to 3069. And in this case, I'm just going to change it to 3069 in the question. I made a typo. So now that we have this, 3069 equals to 3 times 1 take 2 to the power of n all over 1 take 2, or in this case, negative 1. And I'm just going to move this negative 1 to the other side by timesing both sides by negative 1. So now what we have is negative 3069 is the same as 3 minus 3 times 2 to the power of n. Now I can minus 3 from both sides. and I get minus 3072 is equal to minus 3 times 2 to the power of n. Now that I have this, I can divide both sides by minus 3, and that'll give me 1024 is equal to 2 to the power of n. And the number that makes this work is 10. Okay, so 2 to the power of 10 equals 1024. So you would need 10 terms, okay? You need to sum 10 terms in this sequence before you get to a sum of 3069. And that's how you do this question here. Okay, this is our next question. Jerry owns a milking cow. Pretty weird, but we'll go with it. On the first day he milks a cow, it produces 600 milliliters of milk. On each successive day, this means each day after the first, the amount of milk increases by 10%. So what is T7? They're not asking for the summation of anything. They're just asking how much milk does he produce on the 7th day. Well, first off, let's just identify in this question what's even going on. They're saying that you have an initial production of 600 milliliters in a day. So that means A would equal to 600, and I'm going to keep it in liters because I know the numbers are going to get pretty wild. So 0.6 liters, and I know my ratio, okay, so each day from the previous, I know it's increasing by 10%. So from the previous day, I can multiply by 1.1 to get the new production of milk on the next day. So if I want to work out what is T7, I know that's simply going to be the same as AR to the power of n take 1. We can use that formula there. We know A is 0.6. We can times it by 1.1 and do to the power of 6, because in this case n is just 7. We get 1.06 liters to the nearest 10 milliliters. 1.063 liters. So this is how much is produced on day 7. Now let's work out what is S7. So what is the summation of all the milk he produces in a week? So in this case, we can use the arithmetic series formula, the geometric series formula. We can say it's the same as 0.6 times by 1 minus 1.1 to the power of 7 all over 1 minus 1.1. And if we use our calculator, we get 5.692. That's how many milliliters of milk or liters of milk that the milking cow produces in a week. And how many days would it take to produce 10,000 milliliters? And I'm going to change this question just a little bit to say 10 liters, okay, because we're dealing with liters now. So we can do the same thing we did in the previous question. We can say that Sn, okay, we're going to leave it as Sn, is going to equal to 0.6 times 1 minus 1.1 to the power of n, where n is what we're trying to find, divided by 1 minus 1.1. And we're trying to make the series equal to 10. So how many days will it take for this to happen? We can use our graphing calculator or a normal calculator to solve this. And if you do that, you would get that n is simply equal to 10.291 liters. Oh, so in this case, it's meant to be days. Okay, so that means how many days to produce 10,000 milliliters? Well, he doesn't quite get there on the 10th day, or after day 10. So we're going to say n is roughly going to be 11 days. Okay, so that's how you solve this question here. Okay, and this is our last question. A ball is dropped from a height of 15 meters and rebounds from the ground to a height of 10 meters. So I'm going to draw this out each step of the way. So if we were to have a little building here, and we have this as the ground. Okay, so it's dropped from a height of 15 meters. This is 15 meters here. And it bounces back up. So it bounces and then bounces back up to a height of 10 meters. So this height here is 10 meters. Each bounce, it rises to a height of 2/3 the previous height. So after dropping it from 10 meters, from dropping it from 15 meters high, it bounces back to 10 meters. Then when it bounces again, it'll bounce back up to 2/3 of 10 meters. In this case, 6.6 meters. Then it'll continue that pattern. It'll continue that pattern each bounce. So it'll go 10 meters, then it'll go back down, then it'll go up to 2/3 that value, in this case 6.6, and go back down, and then so on and so on and so on. So you need to find the total height when the ball strikes the ground on the 10th time. So what this question is really trying to ask you is, what is the total distance traveled by the ball? Okay, what is the distance traveled by the ball once it has struck the ground on the 10th time? And I'm going to split this question up into two different parts. So we want to work out the 10th time. We can first identify this as a sequence. Okay, all the down passes of the ball as a sequence. And the reason for that is this is a sequence of terms where your height is simply reducing by 2/3. Okay, so it is a common ratio of 2/3 from the previous term. So I can set up an equation that says that Tn, and in this case, I'm going to say for the down passes of the ball. Okay, so Tn is going to equal AR to the power of n take 1. But in this case, it's simply going to equal to 15 times by 2/3 to the power of n take 1. Okay, so that'll tell me the height of what the ball reaches after n number of bounces. Okay, so on the first bounce, it's traveled a 15 meter. Then on the second bounce, on the bound pass, it's gone 15 meters, so on and so on and so on. So let's work out the first 10 of these. Okay, we want to work out the first 10. So let's work out the sum of the first 10 balls. So to work out the summation, the sum of the first 10 bounces, okay, that's simply going to be equal to, in this case, 15 times 1 minus 2/3 to the power of 10 all over 1/3, because we're doing 1 minus 2/3. And when we do this, we get 44.22 meters. So that's how much is traveled for each downstroke. So we can say this is the total distance for the downstrokes. Now what we want to do is we want to work out how much it's traveled for each of these upstrokes. Okay, and I'll do it a different way for now. Okay, so each of these upstrokes, assume that the ball has also traveled this distance here. We can take away this distance in the later, okay, but it just makes the mathematics a little easier. So let's suppose the upstrokes start at 15 meters and they keep decreasing by 2/3 each bounce. Okay, so we can do the exact same thing. We know that the total distance traveled by the red for 10 bounces must equal to the total distance traveled by the blue for 10 bounces. So we don't even need to work it out. We can just say that the sum of the first 10 upstrokes is also going to equal to 44.22 meters. But what we also need to factor in is we don't actually travel this distance of the ball, right? The first distance that we travel is this red downstroke. The ball is dropped from this height and it bounces like this. So we actually have one extra downstroke for each blue upstroke of the ball. So in this case, what we also need to do is we need to actually minus away the original 15 meters. So what we get when we do that is 29.22 meters. So that means the total distance traveled, okay, after the ball has hit the ground on the 10th time is going to be 29.22 plus 44.22 meters. And that's simply going to equal to 73.44 meters. And that's how you do this question here.